Last problem we did on Friday was letter C. Okay, was about between. We did between, right? We did between two weights, 720 and 785. D, we left off D. We didn't do D because it would take, because we're running low on time and we didn't get a chance. This one's not going to take a while, but I want to talk about it more because it's got some stuff on there that we haven't seen before yet in our examples. So we don't have a lot left for the notes. This is the notes. Now, I still want to do some practice problems. So the homework assignment, the classwork homework assignment, this is part of the practice problems, but we're going to spend the next few days doing kind of practice problems because this chapter is made up of questions that look very, very much like each other, but they're different. And like this one right here, letter D. How is that one? It looks the same, right? You read the first part. If we select an adult walrus at random, what is the probability that her weight is? That's the same thing that C said. That's the same thing that B said. That's the same thing that A said. But if I were to give you this question now, a lot of you would stop and pause and be like, what? How do I do that? What's different about this one than A, B, and C?
Asking for IQR, not for a specific weight.
Exactly. They don't give us any weights, right? There are no weights. Doesn't say between 700 and 800. Doesn't say greater than 700, less than 850. There's none of that. They say IQR. That's it. Okay? So for this question here, we're going to kind of do it backwards. We're going to kind of go backwards. So the steps that we've been using: draw and label, shade, z-scores, and using the table to calculate, and then interpreting the calculations. Those are the 4 steps, right? So this question we're going to do a little differently. We're not going to go in order. We're not going to go 1, 2, 3, 4. We might jump around a little bit. Okay, so what do we know? What do we know? So if you're doing this question, remember, critical thinking. You read the question, you hit a wall. You're like, I don't know what the first step is. Well, tell me about what you know about it besides what we've already stated, the question, right? What do we know about it? What do we know about, let's start with IQR. You've seen that chapter 1, a little bit in chapter 2. What's that? Say it again. Interquartile range. Yeah, that's what it stands for. Interquartile range. What else do we know about it? That would might help me solve this question.
It's 50% of the data.
50% of the data, good. Yep, the IQR represents 50% of the data. What else? Okay, the formula is Q3 minus Q1. So Q3 minus Q1. Good. I like that so far. We know that. What else do we know? Dived in a little deeper. What else do we know about it? We know it's 50%. We know it's Q3 minus Q1. We know it's interquartile range. What else? We know a couple other things about it if you dive a little deeper. What else do we know about it? Yeah, Dave. It is. It's 75th percentile, right? This guy right here is 75% or percentile. This guy right here is 25% or percentile, right? So really, we're subtracting those two, right? We're subtracting 75% minus 25%. Think of our questions. Where do we have percents? Where are our percents located? Like for here, where did we get the percent? Not the z-score, the percent. Where did we get that? Or the probability? Where did we get those from? The table, right? The table, let me get my table. The table, all of these guys here, I'm going to shade it in. It's going to be a lot of shading. All of these guys here. And these guys here. These are all percentages or decimals that we can change to percents. A lot of them, right? For this question, that's where we need to start. Those are the two places we need to start, okay? So let me draw a picture first. Let's draw a picture. Let's not skip that step. Let's draw a picture. So I'm going to draw a picture. Step 1 says draw and label. So I'm going to draw and I'm going to label. Start with the mean. The mean has always been 785. What are the 2% that I need to find so that I can subtract? 75 and 25, right? Well, let's start in the middle. What percent is this guy here? Is it 812? 812, yep, looked at the wrong number. Sorry. Yeah, that's definitely something big. 812, sorry. Okay, so what percent, we need to go 75 and 25. What percent does this represent here? 50, right? 50. It's the mean and the median. 50%, that's where the middle is. So 75 is going to be on which side? The right side or the left side? The right side. So we'll say this guy right here. 25 is over here. So what I need to do is find those two question marks and subtract them. That's what I need to do. I need to find those two question marks and subtract them, because this one over here represents the 75%. This one over here represents the 25%. I take the 75% and I subtract it from the 25%. That's what I need to do. Okay? So what do I do? How do I find those two numbers? So we're going backwards. We are going backwards. I'm not going to have to shade this one. I can't do a z-score because I don't know x. Yeah, the z-score, the formula for a z-score is x minus the mean over the standard deviation. And I don't know x. That's what I'm trying to find, right? I'm trying to find x. I'm trying to find the x value here and here. I know this is going to be 812. That's 812. And this is, what was it? All the way to the top, 67. So this is going to be 812 and this is going to be 67. But that's not going to help me. Because if I do that, if I go z-score for, I don't even know what z-score, so x minus 812 divided by 67, I can't solve that because I have two variables. I need to find either z or x. You're not going to take 25% of 812 because it's not the whole. 812 is not the whole. If it was the whole, sure, I'd go for it. Yeah. But it's not the whole. But you're close. You're getting closer there. I'm going to start actually with the percents, the probabilities. Where are those again? Where are the percents and probabilities? Where are they located? On the table. Okay, so let me go back to the table. Let me erase all of those markings. What percent or, yeah, what percent or decimal am I going to look for first? What percent or decimal am I going to look for first?
25%.
25%, right? Because what isn't 25? If I find 25, that starts from here, right? And it goes to here. That's 25%. That's what I want. So what decimal am I going to be looking for if I want 25%? What decimal? Because there's a whole lot of decimals. What decimal? 0.25, or it's got 4, right? So that's what I'm looking for right there. You won't find one exactly, but you'll find one close. Find the closest one to there. Find the closest one and put your pencil or your finger on it. The closest one you can. The closest one I come up with is one of these two guys, right there or right there. 0.2514 and 0.2483. Which one's actually closer to 0.2500? The first one or the second one? The first one, barely, yeah, but it is. Okay, so that's the one I'm going to use. Each of those guys goes with a specific z-score. So what z-score goes with that guy? So yeah, so let's look. Go up, go out, right there. Negative 0.67. Negative 0.67. That's our z-score for this guy here. That's our z-score for this guy here. What's our z-score for this guy? What would I look up here to find the next one? Which decimal would I look for to come up with this one? 75%. Go find it. What do you notice about the one that you find? It's not the same thing. It's what are the same? Z-score, right? The z-scores are the same. They're just exactly opposite signs, right? Opposite signs. Because they're both the same distance from the center. Both of them are the same distance from the center. Where is the center? The center is right here. Center's 812. Both of these guys are 25% away, right? So this z-score is going to be very similar. Okay. I know the probabilities. 0.2500, 0.7500. I know the z-scores. Negative 0.67, positive 0.67. How do I find those? How do I find those question marks now? Now I can plug it in, right? Now I can plug it in. So the first z-score is negative 0.67. To get x by itself, we got to do the opposite. So multiply both sides by 67. Then add 812. What do you get when you multiply and add? $700 and something. $6767.11. Good. Okay. So yep, that's the first. That's the first. This guy here. So I'm going to move this guy over here. 767.11. That's the first question mark. Find the next question mark. What is the next question mark going to be? So you're going to multiply by 0.67. Oh, not 0.67, by 67. Just like you did the first one. Then you're going to add 812 to both sides, just like you did the first one. And what do you get? 800 something? 6.8? 0.9? 0.89. Okay. So that one's going to go here. Okay. Have I answered the question? Am I done? I haven't subtracted them yet, right? So one of them is worth 75. So one of them is 75. One of them is 25. I got to subtract them. So 856.89 minus 767.11. And what do you get? 9. Carry the 1. 89.78. That is my answer. Okay, so now, so I did step 1, then I jumped to step 3. Now I got to go down to step 4, interpret. That's my answer. What does that answer mean? Well, it's the IQR. The IQR is 89.78 kilograms. Okay. These types of problems are very extremely common on FRQs of tests. Okay, they're very, very common on those because it's taking the same thing and kind of turning it on its side. It's using a lot of brain power, using a lot of critical thinking, problem solving, right? Taking what you know, these guys here, these guys are more likely, A, B, and C are more likely to be multiple choice questions. D is more likely to be a free response question. Okay, that's the difference between them. We're going to spend the next couple days doing more problems like D. We're going to spend the next couple days. After today, we'll be done with the notes. Notes we're done with. But practice on these types of problems. That's what I want you guys to practice. That's what we're going to do the next couple days. Okay? Okay, couple things. Let's finish the notes. Let's finish out the notes so you guys can start on your assignment. Okay, so the mean and the median. The mean and the median on density curves. We kind of talked about this before. Where are they located? Well, each of these guys here are not symmetrical. They're all skew, right? They're all skew. So if it's skew, where is the median going to be? Where is the mean going to be? Well, the median is going to be at the point which divides the area in half. So wherever half of 50% and 50%. Now, if it's skew, it's not going to be in the middle. If it's symmetrical, it'll be in the middle. But if it's skew, it won't. Where is the mean? The mean is the balancing point. Is the balancing point, right? Like a teeter-totter, like you guys have seen teeter-totters before, where like you have one side, like you have like this, and then you have something like that. So one kid sits over here, the other kid sits over here, and then they push off, and one goes up, one goes down, right? Well, that fulcrum there, that triangle there has to be put exactly in the middle or else it won't work. It will not work. So what they're saying is, where does that guy go? Where does that guy go? Wherever it goes. So here is the right spot. That would be where the mean is. Okay? This guy is too much on this side. It's too heavy on one side. This side, it's too heavy on the other side. So that's where it goes. That's what they talk about when they say this is only for skew. If it's not skew, it's in the middle, right? If it's like this normal distribution, then it's always in the middle. Mean and the median are always in the middle. Okay, but so that's how to tell. And we talked about why, right? Like for skew right, the mean is going to be a little bit bigger than the median. Skew left, the opposite. So that's kind of like what we've been talking about already. That's why I put it kind of here at the end, because we've already kind of talked about that. Okay. All right, very last thing. The example we'll do tomorrow. The example we're not going to do today because the example is more of what we're going to do tomorrow. It's not notes, it's just a practice problem, but I'd rather have you guys spend time on your assignment than we'll do this example last, or tomorrow. Okay? So the very last thing, assessing normality. So assessing normality means, are these data normal? Like what we did with the heights. Remember what we did with our heights last week? Where is it? Are our heights combined normal? So if they're asking that question, there's 3 ways to do it. A is visual, right? Make a graph. You guys did that, right? The other way is the empirical rule. 68% of the data is within 1 standard deviation, 95 is within 2, 99.7 is within 3. Checking that rule, right? The last one, don't worry about. It's normal probability. I left that on there because it is a way, but they don't test anymore. It's not required in this class to know how to do that, so don't worry about that one. It's important, but you don't have to know it for the test. You don't have to know it or how to do it or how to assess it. Or it's a graph that graphs your actual, so it graphs your observed minus the z-scores. That's what it does. Okay. All right, so the rest, like I said, we'll do this guy tomorrow. This is a great example, but I don't want to do it right now because I think tomorrow it'll fit in better. So what I want to do now is give you some time to do a little practice on your own. So the problems that I chose, these are the book problems. This is just straight from your book. Since you guys don't bring your book, you guys don't have to bring your book to class, I just made a PDF copy of the questions. So this is directly from your book. These questions are directly from your book, so you can check them, the answers at home. Okay, so what I want you to do now, I'm going to give you some time. We don't get a lot of time in class to do assignments like this, so utilize that time, okay, because I have other stuff for us to do, but I thought it would be a good idea to give you guys some time to try it on your own, to practice, so if you need help, you can get help either from me or someone else around you, okay? So I wanted to give you that time. So we got about 30 minutes. So I want you guys to work on that. If you finish it, great. If you don't finish it, you can finish it. It's not due till Thursday. Okay? Wait one second. Let's see.